Hey everyone, so today we'll talk about Hashicorp Vault. So it's just an introductory session over here. So we'll get started over here and we'll see what we gonna learn over this session. So in this session, we are covering about the introduction to the vault, the secrets, what are the secrets, the vault architecture, what are the installation prerequisite which we have, and then we would be have a quick session on the installation part. Right now, what we would be doing is we would be doing the installation in our Mac OS, but the same point of moment, the commands are given for the Windows and Linux. So let's get started about what is the vault. So HashiCorp Vault is more of like to help the organization to actually access all the secrets and transmit it safely in the within the organization. So let's suppose a human is doing so, right? In that scenario, when a certain human is passing down the secret to a different human being, that point of moment, the revoking or the leasing of the secrets is pretty hard. It's just because you can't revoke a secret from a person. You have to change it. And once you change it, you need to again redistribute it to the different persons, authorized person, and the machine. So it's a pretty complicated task or the operational task to do so. That's why we had this HashiCorp designed for the organization to manage all the access and revoking, leasing. These operational stuff can be handled by the HashiCorp pod. It actually makes easier to access, uh, means having a unilateral interface where you can actually save all your secrets with that defined paths, the classification of the secrets. So let's suppose you have AWS, so the AWS authentication would be different. The GitHub authentication would be different. There is a token access mechanism. So these are kind of features which HashiCorp's Vault uh, provides, and we would be talking about this in the later sessions. Similar to that, now this is more of an introductory part that it's a secret management tool and designed to handle all the sensitive credentials in a low trust environment. So when we say low trust environment, what it means? So it actually means a environment where we actually don't much depend on or don't trust on the peoples. So there is a zero trust environment, there is a low trust environment, and there is a high trust environment. In a high trust environment, we basically rely on the peoples, whereas in the low trust environment, we basically rely on the process or the tools which is there for the management, the secret management. So there are many ways to actually use the HashiCorp vault. One is the secret management, one is the identity-based access, right? So let's suppose I'm a person having a privilege of all secrets, whereas in the second person, the person B would be having a limited secret access. So that is again goes into the identity-based access. And then each and every secrets are actually encrypted. So so when we put our key vault secrets at that point of moment, it actually store in the backend in an encrypted manner. That is the beauty of HashiCorp Vault. Now we have said many times secrets, sensitive credentials, but what is actually a secret and how do we actually distribute them? This is one of a topic which is more of a debatable topic, how to detect the sensitive information. So all information which is very security sensitive, it means if we leak them, it actually hampers our security. It actually hampers our it actually hampers our local breach. It actually have a local breach. At the same point of moment, any information which can easily identify the identity of an entity. It means we can actually detect the identity of a person. So this was all about personally identifiable information, whereas these were when we talk about human to human interaction, whereas when we talk about human to machine or machine to machine credential, it would be more of like baby user credentials, EWSAN credential, or a profile credential, whichever is sensitive to the machine. So these are treated as in secrets, and when we distribute it, we take it into the consideration that to whom we are distributing it, to till what time we want to distribute it to, and when we want to revoke it. So these were few constraints when we distributed secrets. So these all were done or handled by Vault. Right now, what you are right now seeing is more of an vault architecture. It's bit of a classy architecture, I would say, which start from the upper layer of HTTPS API. So one of the thing which you should know about Vault is that Vault is a REST API based having a mechanism. So that's why the upper layer would be in the HTTP or the HTTPS API based on the configuration done by it. Then we had this token store, rollback manager, the core mechanism, the policy stores, the expiration manager, and the audit brokers, audit devices. So these actually, so when we say token store, so there is an authentication mechanism placed in this whole barrier, I would say, where we store the token for the authentication, and that is where the token is getting stored. Whereas we also write some policies for each and every secret, which we say as in security policies, which is stored in the policy stores. Whereas in the expiration manager actually tells, or the rollback manager actually tells about the leasing or the revoking mechanism for the Hashicorp Vaults. Audit broker, whereas in the other hand, handles all the audit audit based mechanism, like when the secret was leased, when the secret was revoked, to whom it was given to, when and what time it was accessed. So these kind of information is audited by the audit brokers and the audit devices. Whereas in the core mechanism handle all the path routing mechanism, where we can see, so let's suppose we have a path, since it's a REST API. Based on the path routing, it actually goes to the secret engine or the auth matter or the system backend to find the specific credentials based on it. So when we say path routing can be done for the authentication too, since it's a REST API. Whereas at the same point of moment, path routing can be done for getting the system information too. Whereas it also, and the primarily objective to have this path routing is for getting the secret from the secret engine. And the secret engine actually communicates with the storage backends. Now, there are two types of servers and HashiCorp vaults. One is the dev server, and whereas in the second, we have a production server, so the dev server is for all doing the dirty work around the policies, the token, and the secret itself, so that when we promote it to the promotion or the production in environment, at that point of moment, it won't have a issue. So this was all about the vault architecture, I would say. Now, when we talk about the installation prerequisite, each and every OS have their own package manager. So when we say Windows, in Windows, we have a package manager of Chocolatey. So Chocolatey manager actually helps to install a package in the Windows, whereas in Linux, we don't need any kind of such prerequisite because they had their inbuilt package manager. Just like for Ubuntu, we had this apt package manager, and for the CentOS based, or we have this yum package manager. In Mac OS, our current environment, we had this homebrew package which can be installed. So I have provided the link in each section. You can just browse to it and get it installed. In my case, I have already installed Brew. So what I'll do is I'll just go for Brew and install it. So right now, this workspace which you are seeing is called as the Visual Studio Code. So in Visual Studio Code, I'm writing down all the information which is there so that you can see it. Now, if you can see, it's installed, right? So let's go for Vault. Yeah, you can see it. So we had this Vault ready. Now you can see we are getting this error, connection refuel. This is because our server is not started. Now, like I said, we had two types of server. One is dev server and one is production server. In our next session, we're going to talk about what and how we can start a Vault dev server. Till then, thank you.